Yeah, I'm super excited how the project went, the launch, and I've been getting many questions, many technical questions in the chat, and also some questions kept repeating. So I thought it was good to do a video session so you could also like on the fly ask questions back. So I will give a short introduction how I came to Mutant Garden, how it works, and then I will start to answer some of the questions that I already got in the chat, but feel free to add some more. So if you can all see my screen, this is an example of an earlier work that I made, which is also using genetic algorithms. I've been working with genetic algorithms for quite a while. You could say I'm a generative artist for quite a while. And what bothered me in generative art was often that it was the randomness element was very strong, and there seemed to be very little direction. So I thought, how can I make generative art using genetic algorithms where there is a certain direction, there's progress, there's like one is better than the other. So this is an older work from 2014, 14 or 15, no, yes, 2016, I think, where it's also online, hybrid figure. I will post the link in the chat later, where you can actually pick two. Let's say, let's also call them mutants. At that time, I didn't call them like that yet. Specimen, and because I'm picking two each time, the the strategy of procreation is crossover. It's not mutation. So you need two parents all the time. You can see them gradually become more similar. Mutant Garden works a bit different because Mutant Garden only works with mutation. And the immediate thing that I stumbled upon was the problem when you mutate computer programs, because each mutant is in essence a computer program. Almost all mutations immediately ruin the computer program. If you change one bit in a computer program, most of the time the computer program just completely halts and breaks. So I was looking at some of the academic literature about evolutionary programming, and I found this algorithm called Cartesian genetic programming. This image might look very complicated, but what it basically does, it proposes a way to encode computer programs in a sort of chromosomal structure, which is this genotype. And that translates to a two-dimensional graph where each circle represents an instruction. And the cool thing about this is that you can mutate indefinitely without the program ever crashing. There's no the halting program. The problem is solved. I I mean this drawing is very incomprehensible. So I made a animation that should maybe somebody has the microphone still open. Um, so the drawing I just showed you with those circles and lines, this is another representation of the algorithm. This is also available on my website. I don't know if anybody already discovered it. I posted it in the Discord a few times. So this animation shows how the Cartesian genetic network, all those little lines and colors, how those encode the drawing or the mutant that you see beneath it. And each circle is a gene. And you can see that some genes are used and some genes are never used. So many people ask me, what are coding genes? So if you see this two-dimensional structure of layers and nodes, then let's say this one, I don't know exactly, but let's say it has 50 layers and maybe 20 nodes on each line. So 20 times 50, that's the amount of total genes we have, but only a few are used. So that's the percentage that you get in an OpenSea. Where did it go? Anyway, here. So for example, this mutant here, this mutant has 9%. That means that from all the genes that it has, so all these, oh, it's reloading. From all the genes that it has, only 9% of those are actually in use. And mutations are most interesting visually when you can actually notice them. So I made the algorithm in such a way that it favors mutations in nodes or genes that are already in use, because that way it is more likely that you can see it. So that means that gradually the coding genes property gets higher. There's also a description of this more like. So during the traversal of that graph, this graph here, the the amount of nodes that are visited, like touched, within one traversal divided by the total of these times 100, that's the percentage. So this value changes over time, and it gradually gets a bit higher. So it means that also in the first, like, I don't know how many, but in the first phase of mutations, let's say the first 100 mutations, I don't know, the visible mutations will be quite large because the amount of coding genes is very low, so it can only pick a few. But gradually, the mutations will tend to be visually more stable and subtle. Maybe I should also check the chat while I'm talking. There are a lot of activity here. Okay, cool, it works. So in this case, this visualization shows on the top left, it shows the color palette, and the nodes are flashing when that color is used as an instruction. So each instruction each node could mean something like draw a square, or it could mean make the color number 3 a bit more red, or it could mean split the current space in two. So these are the instructions that are encoded in this graph. I mean, this Cartesian genetic network is very simple. This is a calculator, so the instructions that this one has are just arithmetic. In my case, the instructions that are in the nodes are not plus, minus, star, or multiply or divide, but the instructions are draw a circle, draw a line, make the current space a bit smaller. Yeah, here you can see it traverse. So this one died already. Now it's probably restarting again. So I would recommend, if to understand the way how the sorry. No, nothing. So it's a bit tricky to explain how the Cartesian network works, but I would recommend to read that text on the about page, and also check out the longer text and the interview that I had with the inventor of the algorithm. And it was super cool. I contacted him and told him that I used this algorithm to make visual art, and that I don't think happened much before. So he listed my implementation in TypeScript as an official implementation on the Cartesian genetic programming website. Many questions that I've been getting were about mutability and immutability. And I think one reason to start this whole project was, in a way, sort of a provocation of the idea that NFTs are immutable. And this is kind of a sensitive issue, I think, in the NFT space, where in the ERC 721 standard, we have very well organized the information about who owns what. We have a record of transactions. We know how much something was bought or sold for, when it was minted by whom. This is all very clear. So it's really clear who owns what. But the question of what it is that you exactly own and where this is hosted and who has control over that asset is, I think, sometimes a bit elephant in the room. And so I decided that this project is kind of putting that fact as the center of attention instead of hiding it, that NFTs are actually mutable, or to show that as like the core principle of it. So it's an NFT that changes, and that introduces a whole range of new questions and challenges. And yeah, in this case, Damon Ciccone, he's another let's say net artist from my generation. And he suggested that NFTs, the problem with that, or why he didn't like, is that they can't change. And what he said was that the primary, most radical aspect of a digital work or selling a digital work was its mutability. And I told him, maybe I misunderstand, but you can actually change what it references. And I think all these changes, all these decisions in design, in an NFT, in the metadata, where it's hosted, the file storage solution, all these are project-specific, NFT-specific decisions, design decisions that can also change over time, ideally. And I hear alarm clock. Is it here? Okay. And also Billy Rennekamp wrote a really nice, really interesting Twitter thread about this, where he is also suggesting that in a project, to remain agile and to be able to improve a project, to work on it, and also adapt to changing requirements, it's good to gradually implement decentralized storage of both the metadata and the assets. And I'm working on this now currently. So this project is weird in the way that most NFT projects, the assets are generated upon minting. And once the NFT is minted and the assets are generated, the files are kept in either IPFS or Arweave or Filecoin or whatever. And from there on, they don't change. But in my case, with Mutant Garden, that is the whole kind of, I guess, novel element of it, is that the work grows and it changes over time. So I have to continuously add files to the storage. And this is an interesting new challenge that I'm working on, also with the rest of the Folia team, to see what makes sense. I think it's completely fine that currently the assets are both generated on a server and hosted on a server, a centralized server. But gradually, I want to migrate the rendered assets that the server renders to a decentralized storage solution. The longer-term question is what happens to the calculations, because currently the calculations are executed on a server daemon. Could actually show what it looks like. Maybe here. No. So each block, all 513 mutants are compared to the current block, and it's checked if any of them has mutated. So this happens on my own server, and that's a centralized server. You could consider this daemon to be a sidechain in a way, and it's a read-only sidechain. So it does calculations, it renders assets, but it doesn't write information back to mainnet because it's not necessary. So this month we will release a standalone Electron app that you can run on your own computer for Windows, PC, and Linux, where you can also calculate your mutant. And this app is connected to the internet, and it reads the current block transactions. So that way, the rendering of the assets is also decentralized. And that brings me to another big question about NFTs that I find very fascinating. Let's see, where's the slide? Because the question of what exactly is an NFT? If you look at this is the official specification. This is the JSON schema for the metadata file, and you can see it basically only suggests 3 fields: name, description, and image. And I think it's very important and interesting to think about if that image represents a documentation of the artwork, or a thumbnail, or a low resolution image of that, or a video still, or if image should actually refer to the actual artwork. And I think this is sometimes confusing. And I see, for example, on Foundation, image links to a video file, and that's maybe still okay. But in my case, the mutant, let's say the whole artwork of one mutant consists of a series of mutations and SVG files that belong to that. So this is why this Electron app is important, because it allows everybody to render the assets of their own mutant and play around with it without depending on my server or on anybody's server, except that it will make a call to the internet to get the current block hash. And that way, that is also a decentralized storage solution. You just render the asset yourself. The only question then is, because the metadata of the ERC 721 token points to the most recent mutation. But still, I think it's important that this keeps being updated. And I once mentioned in the about page that if for some reason my server daemon would not update the assets anymore, then that would be sort of a fossil on the metadata file. But you would always still be able to run the mutant on your own desktop and have it updated to the current state. Let's see. Yeah, so when does a mutant mutate? There's many questions about when or why, or can you predict how often it mutates? And I cannot know exactly, nobody knows how often a mutant mutates, because it's based on probability. So I'm here, for example, I'm here on Etherscan. So let's say that this is the current block. And this is the hash of the current block. Each mutant, let's say I have a mutant that is born on this block, like 1,000 blocks earlier. So let me first copy paste this. So this is let's say this is the current block. And it was born on this block. So I take the transaction hash of that. Okay, so this is the transaction hash of the birth block. This is the transaction hash of the current block. What I'm doing for each mutant, for each block, is that I'm checking how many digits are similar. So I have to tell you though that I'm not doing this on the hexadecimal ones, but I'm doing it on the binary one. So I take a binary representation of what you just saw hexadecimal. It's much longer than that. So let's say let's say this is actually impossible. It has to be lower. So some mutants say that each of the some mutants need, for example, 5 digits similar. That would mean that it's checking 1, 2, 3, 4, 5. Unfortunately, this one is not the same. So next block it will mutate. Let's say that the block that comes after that is this, and we need 5 digits similar. In that case, the birth block corresponds with 5 digits to the current block, and that means it will mutate. And if you would say that each Ethereum block takes about 12 seconds, then you could say that if you have 1 digit similar, then you could say that every second block you have the chance of mutating. So it will mutate every 24 seconds. If you have 2 digits similar, then it's each 4 blocks. Is my math correct? I think so, yeah. So what happens when it mutates? I can actually show the code here. So this is the code. I don't know how deep you are in coding, but maybe it's fun to see. I will actually release all this code on a public repository. So I will also accept pull requests on that. So it's looking similar. It means, so it converts to binary, and it needs a certain amount of similar digits. Then it mutates. It says, okay, on block this number, you have so many similar hashes, and then it mutates, calculates it, caches everything, and after mutation, what it also does, it pings OpenSea to request a metadata update from the OpenSea API. I was really glad that OpenSea actually supports this. And then this is newly generated, and you can also see that I included the timestamp of the current refresh, so you can see how long ago the metadata has actually been updated. Let's see if there was some questions. In which channel are most questions now, or are there no further questions? Is it okay? This is a good one. Question: is it possible after many mutations, human eye can't distinguish further mutations? Yes, this is possible, but at some point it's unlikely. So you can imagine that in this network of genes, that some genes contain instructions to draw something, but some genes also are just a terminator. It's just an instruction that says don't parse further, or it could be an instruction that says jump to the next layer, and then it finds a terminator there. So there are many mutations that are not immediately visible. That is possible, but at some point, and that's why I made it biased to mutate nodes that are already in use. It's highly probable that mutations are visible. I could have also completely at random allowed all genes to mutate, also the ones that are not yet coding, but then the chances of seeing visible mutations would be much lower. So it means that gradually the coding genes percentage is growing, it's increasing. I will now sort some of the questions I got in the chat. So are there any plans to display the 530 mutants again somewhere in physical or metaverse gallery? Yes, actually the whole project is going to be exhibited at a big German museum. We're looking into possibilities of how we will show that. I have printed some of them before, but those were not the NFTs. Also, we've shown them on square screen. My work is usually flat and two-dimensional, and I'm really inspired by user interfaces that are flat. And maybe I'm old school. I also wasn't able to play Mario once it got 3D because I got used to the 2D version. But I don't really relate to metaverse 3D worlds. But I think it's cool, but I never navigate them myself. But maybe in the future. Um, what digital frames did you use? Where can we buy them? I've been using ISO, and they're like I think about a little under $1,000. That's quite expensive, I think, but they are really beautiful. Somebody is asking in the chat which museum it is. I cannot disclose the museum yet. How were the names chosen? Yes, so I wanted names that had some kind of human familiar ring to them, but then we're also a bit off. So what I did, I found a list of about I think 1 million common, let's say European names, and I cut them in chunks, and I reconfigured them also based on the Earth block transaction hash. So the names are algorithmically driven, and I was surprised because the algorithm that I used for this was actually quite simple, or I mean, relatively simple, but that the names that came out really feel like real names, but then also as if they're from like a parallel universe or something, like Rick and Morty names. Um, yeah, this is a good one. I also referenced it a bit earlier. So fossil would only happen, like a mutant would only. I mentioned the word fossil only if the mutant garden cedar daemon would stop updating the metadata and would stop uploading the rendered assets to a server. So, I mean, that I don't think that's going to happen, but wouldn't we be able to algorithmically create mutations without help? Yes, you will be using this Electron app that you can run on your own computer. So you can imagine that this Electron app, you fill in your wallet address where your tokens, where your mutants are, and then it loads your mutant, and it synchronizes to mainnet. It loads the transaction hashes, and then locally renders your the SVGs that belong to that. And this is scheduled to be released this month. So, as owner of the NFT, do we have reproduction rights to our NFT, resale rights? Let's see. I like this license. I think it makes sense for this project. I know Creative Commons are a bit old and maybe cannot be really enforced, but I think people should be able to share it, play with it, remix and do whatever. I would like to be attributed, and I wouldn't really like it if somebody makes copies or changes and then sells those. But this is all. Actually, I'm not an expert in this, but I think this would be the license that I would use for the usage of SVGs. I also believe that if somebody bought the NFT, I really believe they really own that artwork. So I would be glad to advise them on how to print it or how to show it on a screen. Can you explain more about the behavior related to the coloring complexities in coding genes? Yes. So if I start with complexity, if you see the Cartesian network here, then from top to bottom, those are the layers. And I would guess that this one has about maybe 60 or 70 layers. So the more layers a mutant has, and the amount of layers is also again based on the transaction hash at birth. The more layers it has, the higher complexity it has. And I could have in OpenSea, I could have just put the number. So instead of complexity agile, I could have just put the number here, like complexity 1 or 2, but I didn't think that would really like mean much to people. And so I made categories. Let's see. Um, so for example, the amount of layers, the minimum amount of layers is 32. The maximum is 78. And these numbers I have decided on by carefully testing and repeating and figuring out what ideal is, what works, what is not too heavy to calculate, but still has the broadest range of visual appearances. So from 32 to 78 maximum, I have put them into categories. So 1, 2, 3, 4, 5. So there's 6 categories that I have split. So I've made discrete units of these numbers because I think it's more meaningful. And that's the same here with the let's say there's also the layer size and the disk and the memory size. I think I will add these to the metadata as well. So there would then be more properties here, but that's in the making. I'm still researching this if that is like meaningful to add that. All the existing properties will not change. So the amount of layers that a mutant has is fixed upon birth. It will never change. Even when I add new attributes to the mutant, those existing ones won't change. Then there was a question related to the coloring. Yes. So, for example, this one has a balanced coloring. That means that it's the HSL color space. So for people familiar with like Photoshop or other visual software tools, you can specify colors in multiple ways. Most commonly used, the most familiar are people with red, green, blue. But then in case of red, green, blue, you would get really bright and intense colors because at some point when one channel of if like red reaches a value of 255, you cannot go any higher. So the colors tend to be quite intense. So I thought it would be interesting to also work with a different color space, which is a hue, saturation, lightness. So instead of adding colors, like instead of mixing colors, it's more like you have a sliding scale of all the colors, and then you can adjust the saturation. Like zero saturation, it's gray, and full saturation, it's super bright. And the L would mean how dark it is. So if the L is zero, it's completely black. If it's 255, it's really bright. So some mutants are built have a palette that consists of RGB. So the palette is these lines here. So this mutant 1, 2, 3, 4. This mutant only has 5 colors, and I don't know which color space it is, but I could guess that this is actually HSL. So some mutants have only HSL colors, some only RGB, and some have mixed. So that means the balance, and RGB tends to be have high contrast. HSL tends to be a bit more like introvert colors, more gray, more pastel, and mixed would be both. So, for example, I would like to know what the effect of agile is. So, agile is one of the discrete categories of the amount of layers. So I would guess that would be around maybe 60, 60, 61, 63. That would be agile. Where was I? Yeah. Can the coding genes change during lifetime? It's not even can they, but they will for sure. This property changes most of the time. It gradually increases, but it could be that one mutation just cut off an entire branch. So instead of the instruction could have been like go to the next layer, but maybe it mutates to an instruction that says stop executing. Then suddenly there could be a drop in coding genes. But generally, I think it increases. Is there anything the community can do to support the project? Yes. So I am going to publish the Mutant Garden either website in an open repository so people can look at it and file issues or pull requests. Also, the standalone Electron desktop app will be open source, and this will, yeah, this would be great that people can look at how it works. Also, write issues and file pull requests, because that's basically, I think, in this being able to recalculate in a deterministic way the mutations and the development of the mutant is very essential. And this needs to happen also without any dependence on my server. Let's see. Yes, I think also somebody asked me what my favorites are. I certainly have some favorites. Let's see. Somehow I'm really into these colors. It is a bit of an older one. I minted it. It was one of the first 64 that I pre-minted. So maybe it's also my favorite because I picked it myself. I think this one has a very good. Yeah, I like the complexity of this one, and I like the colors. So you might have noticed that the mutants actually are also transparent. So it's not only they don't only change in time through mutations, they also change, as you probably know, in reconfiguring the window, but also they are transparent. So if you would have a different background, they also change. And all of this is kind of a provocation to this idea that NFTs are immutable. So these mutants change in multiple directions. And what I like about is that even though it changes, that each one still has their own um, character or identity. So you can see it change, but it also there's some kind of unexplainable visual essence to them. Maybe I'm getting a bit lofty here, but that's what I like about the project. One of the features that I want is also in the responsive window to have an auto loop where you can also see a change in this aspect ratio. The Electron app will have that, and it will be full screen. I'm also considering to make a screensaver that shows your mutant. It just that might probably in first instance only be for macOS, making the screensaver. These will the Electron app will just be downloadable from the Mutant Garden website as a precompiled binary, and the source code will be on GitHub. Let's see if there are many more questions in the meanwhile. What? Yes. Oh, that's a good one. Yes. Okay, I'll start with, are there art, historical, or biological, human, technological points of reference that come to mind strongly in the conception of this project? Yes, if the long story is here that I years ago saw a video by Vinay Gupta. I probably pronounced his name wrong. Where he was posing this, or like he was saying that like 10% of the relationships in let's say in Europe are built using dating apps. So Tinder, all these, all the dating apps. So, and these apps have a business model to make sure that people also come back to the app. Because if they find relationships that immediately work well, then they will not return to the app. So his position was that the dating apps, they need to be adjusted in such a way that they will make fun but not long-lasting relationships. And I thought it made sense. If you have a neural network trained with this target of maximizing profit by visitors, then the neural network will not be optimized for finding ideal long-lasting relationships. It will be optimized for short-lived, explosive relationships. And I thought that fact alone was interesting. But then if you consider that, and also the children who might be born from these short-lived relationships, it's just like biopolitics, you know. It's like the neural network optimizes the DNA that people have in procreation. And I was just wondering what are the repercussions of this. And this is when I started using or researching genetic algorithms. So that was more like a human psychological point of reference. Aesthetically, let's see. In my recent solo show, I showed in one room of the exhibition, the Mutant Garden exhibition, I showed also on these LED tables as artworks. I showed my, let's say, inspirations aesthetically and in painting, because I thought it was interesting that with my algorithm, I could kind of produce particular paintings from artists that I admire, just as sort of presets of my algorithm. So some mutants could hypothetically be the same as paintings like these artists. So in a kind of cheeky way, I mixed, like this is Sarah Morris. The left one is Sarah Morris. This is an algorithm by me. Sarah Morris, Gabriel Orozco. This is me again, and Peter Halley. So those are some painters that I found interesting here because they use similar geometrical, let's say, programmistic paintings. I don't think they use algorithms or they don't have much rules. I think they do it very manually, but these are definitely points of reference for me. What do you think these will look like in 3 years? Yeah, it's a good question. I have tried to mathematically figure it out. Mutants tend to mutate towards higher complexity. That's my finding. So I guess they will be more complicated. It is also a bit scary because that means that they also require more processing power. But then if we balance this with Moore's law, as long as that is still valid, then that should be fine. So I guess it will mutate towards higher complexity. And also the computer screens are getting higher resolution. So the artwork is SVG, and SVG is rendered really well also in the browser and also respected by OpenSea. So they are future-proof in terms of resolution. Can you explain the usage of the mutant feeder contract versus the feeder controller contract? Yeah, this is very much by the genius mind of Billy Rennekamp. Having also with this idea of immutability, it's really good to be able to later change functionality also in your smart contract if you find out you made a mistake or there's a problem, there's a leak or whatever. So the most simple ERC 721 standard logic is in the mutant feeder contract, and that is really basic. So the only thing it has is the standard methods, and it has a by function. All the logic of making sure that the token ID is unique, making sure that it has proper metadata, that is all handled in a controller contract. And in the future, we can still update if we find mistakes. There's even a third contract which is used, and that's the metadata contract. So currently, as it references just an HTTPS server. If this would be an IPFS server, well, I mean, there's not really IPFS servers, but IPFS endpoint or something else, then we are still free to do that without changing the ERC 721 contract. So this is a lot of information, and I don't know if I think in particular the concept of non-coding genes is complicated. It really has its roots in biology. I don't know the numbers, but I think the vast majority of our human DNA are actually non-coding genes. Or sometimes we think they're non-coding, but then later we find out that they actually played a role. The amount of the low amount of coding genes in Cartesian genetic programming, which is is known is actually really an asset of it, because it could mean that in one mutation, an entire new branch or subgraph can be activated or disabled. But if you really like to understand it better, then you should read up a little bit about biology and also about Cartesian genetic programming. I think the only thing for like more like a consumer point of view is to know that the value changes, and it most likely only increases a bit, but maybe sometimes it jumps back. There's one thing that I want to show because I've also been getting many questions about that. And that is more like an interface thing from OpenSea, because people've been looking. So this particular mutant, it mutates twice a month. It hasn't mutated yet. It's 0. But where does this number come from? What is it? And actually, I'm not so happy that OpenSea shows this number, but But this means 44 is the max amount of mutations that any mutant has mutated. So there is at least one mutant that mutated 44 times. So if that mutant mutates another time, then this would display 0 of 45. So this number is not fixed. This also changes over time, and the mutations are infinite. So how do you think a monetary value can be placed on a work like this, which is unique in the NFT space and does not have many? Yeah, maybe I can get away with being like a romantic, naive artist and say that actually I don't really know much about monetary value. I'm more like a, I don't know, artist, philosopher, coder, and I like to make interesting projects. Obviously, the drop has changed the life of me and my wife and my son a lot. So yeah, I I think I hope that the discussion about mutability and immutability and lasting storage versus flexibility in changing things, fixing things. So I hope that discussion is being held, and yeah, and it would, and the value, I don't know much about the market actually. What will last longer? Humanity's ability to increase processing power of mutants. I don't know. And if I would say that the mutant is actually defined by its birth block and mutation blocks. That's the genotype, and its appearance, it being rendered, doesn't influence its existence. In other words, one mutation exists and keeps mutating even if its assets are not rendered. It's just that nobody sees them.
If anyone has any questions in the voice chat, let us know. I think we're going to be wrapping this up soon in the next few minutes, so it'd be great if you have any more questions, throw them in the chat, or feel free to speak up here.
Yeah, I like this question. Speaking of the SVG format and OpenSea, will it ever be possible to view mutations in multiple platforms? Yeah, so I've been researching WebP as a file format, and WebP actually supports animation. So it's like animated GIF, but then without the low quality dithering. So I'm considering to also add that to the metadata, so you would have the SVG as the last mutation as the thumbnail, and then if you would click, you could get a WebP animation, something like this. I think that would be nice. So when block time speed up, we get, yes, this is actually didn't even realize this, but yeah. the mutation rate is fully dependent on the time it takes to process a block. So if it halves, then you get twice as many mutations. That's cool. Actually, that's really cool. Yeah. Any more questions still?
It looks like Travis is typing. Maybe we'll have Travis be the last one. Okay.
Well, thanks for listening, Travis. Also, your work is great. And I'm also in the Mutant Garden chat. So if you have other questions in another time, I'm glad to answer them.
Thank you so much for doing this, Harm.